All right. The second kind of chi-squared you can do is called the test for independence. And you do this when you wanted to see if there are two qualitative variables that are related to each other. So it's conceptually similar to a two-way ANOVA in that you have two different things and you're looking at if they interact in any kind of way. So it's kind of like the way the two-way ANOVA looks for an interaction. So this is I took from a real study that we'll read shortly here in the course. The example, do drivers of luxury cars, are they less likely to yield for pedestrians in the crosswalk? So I won't go into all the theory, but the researchers had this hypothesis that richer people should have certain sense of entitlement and that they may behave in ways that are less than fully ethically and morally astute. So they did this study where they had pedestrians stand on the side of the road, put a foot in the pedestrian crosswalk, which is supposed to give them right-of-way, and then they checked to see if the cars stopped. And they kept track of two things. They kept track of whether or not the car stopped and whether or not the car was a luxury car. So either like a BMW versus, say, a Chevy. Not that Chevys aren't very nice cars. Okay, so what are the two qualitative variables that they're looking at here? One is whether or not the car was luxury or standard. So that would be the first line here, type of car. And the second thing was whether or not the car yielded. So whether the car stopped. Okay, so the way you would set that up is kind of looks like a two-way ANOVA, where you'd have the type of car, luxury or standard, and then the other thing you're looking at, in this case, whether somebody yielded or did not yield. So I've given you this space and this space to work it out, and I'll do it as well for you. Okay, so the numbers that are here, let's say those are your actual observations from your study. So in other words, this means that 25 standard cars did yield at the crosswalk, 15 standard cars did not yield, etc. So the first thing we need to do is get the totals for the rows and columns, and that will help us get the expected frequencies. So what we're going to do is total across this way, and then total down this way, and then you'll get a grand total. So the way that works is 10 and 25 is 35, 30 and 15 is 45, etc., etc. Then if you add this way and this way, you should get 40. Once we've done that, that allows us to get the expected frequencies that will go in the lower half of each cell. So here are the steps that you're going to work through. First, you're totaling the observed frequencies to get the ends, and then we're going to get each cell's expected frequency as follows. You're going to take the column times the row total and then divide by the grand total. So that would be 40 times 35 divided by 80 is 17.5. 40 times 35 divided by 80 is 17.5. 40 times 35 divided by 80 is 22.5. And then 40 times 45 divided by 80 is 22.5. And now we're ready for step 3 here to plug each of these cells into the formula. So that would be the 10 minus the 17.5 squared divided by 17.5, then the next cell, the next cell, then the next cell. So you can pause it here if you want so that you can copy all this down. Okay, and then we would add or resolve each of these quotients or simplify each of these quotients. Something divided by something is a quotient. And that will give us these numbers. And then if you add all those up, that gives you 11.4286. And that, of course, is your chi-square obtained. And then we need to find chi-squared critical. So we take the degrees of freedom are going to be the number of rows minus 1, number of columns minus 1. So that's number of rows minus 1, so it's going to end up being 1 times 1. And that will give us a chi-squared of 3.841. So you're going to end up rejecting the null hypothesis because the chi-squared obtained is significantly or is larger than the chi-squared critical. So you can say that the luxury cars are less likely to yield to pedestrians. So in other words, these two variables, car and behavior, they interact. They're not independent. We show that there's a pattern here where the standard cars are more likely to yield and the luxury cars are more likely to not yield. That's what it means to reject the null hypothesis in this case. Okay, and just to clarify, if you're going to go out and try to cross the road, it pays to be in a large group, especially if you're short and feathered. You want to have a lot of fine feathered friends, so to speak. Somewhere around 30 is usually a safe number. That's what I recommend. Okay, example number 2. Here we're going to look at pro-social orientation or social orientation and helping. So there's a research tradition where you can categorize people as competitive, independent, or pro-social. Pro-social people like helping other people. People that are independent want to maximize their outcomes. They don't care about other people. And people that are competitive want to maximize their outcomes relative to other people. What they care about is winning. So the pro-social, they want everybody to be in a nice house. The independent, they want to be in the best house. They don't care about anybody else. And the competitive, they want to be in a house that's bigger than other people. So we start off here with the number of observations we have based on our sample of people that were categorized as this and whether or not they helped in a particular situation. So you drop something in the hallway and you see if they helped or if they just sat there and snickered at you. So to warm up for this, so I give you a workspace. I want you to take notes on this as you go. But I want you to consider what's going on here. Is the turtle being pro-social, or is this more some kind of pro-turtle wrestling? I don't know. It's kind of hard to tell. You want to see it again? Let's watch that again. Help! 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 Boom. So I think it's pro-social. I don't think he was being mean. Okay. So we got our observed values, and just to recall our steps, first thing we want to do is get the column and row totals for the observed frequencies. So that means we're going to plug in, figure out what these values are. So these would work out to 26 and 20, and that'll give you a hint. This adds up to 56. And so what that would do then is enable us to get this cell's expected frequency. So we're going to take 26 times 20 divided by 56. Shazam! That's 9.286. So take a moment, see if you can get what these two other ones are. Hit pause while you do that. So you should have gotten 30 and 19 and 17. And now you should be able to get the expected frequencies for these other cells. So hit pause and go ahead and do that. So this is what you should have gotten. Again, the top value is the one we saw. The bottom one is the ones we'd expect to see if the distribution, if these two variables are not related to each other. Okay, so now we need to figure out the chi-squared formula itself. Remember, that's the formula. So I'm going to work out this first cell for you. It would work out to this. 7 minus 9.29 divided by 9.29. So go ahead. You got 1, 2, 3, 4, 5 more of these quotients to do. So go ahead and do that. Hit pause. I'll wait. Okay, so you should have gotten these formulas here. You want to hit pause for a second and check those. That's fine. Okay, so that means those would resolve to as follows. And it gives you a chi-squared of 3.476. So what can we do with that? Well, the degrees of freedom are going to end up being 1 times 2, because remember, it's number of rows minus 1 times number of columns. Excuse me, number of rows minus 1 times number of columns minus 1. So it's 2 times 1, or 2. That gives us a chi-squared of 5.991. So in this case, we don't beat the chi-critical number. The chi-squared is critical. We have to retain the null. And that means that in our little study here, we did not show that people that are pro-social were more likely to help. Now, when you just look at the numbers here, you're saying, well, yeah, they ended up helping more often than not relative to these other groups. But again, we're saying relative to sampling error, we can't be sure of that, so we're going to have to end up retaining the null. Okay, then let's close on a note. Is this dog being pro-social? Let's see. Looks pro-social so far. He's saying, get out of my way, people. I'm coming through with the kid. Then he comes over here. He kind of scares that dog. There's some bad talk going on there. And look at the kid, how focused he is. He really wants to be a good driver. Should you watch that? Let's watch that again. He's driving along. He comes over here. He's going to scare this other dog. He's going to go, wah! And this dog goes, back off. And this guy says, ha! He's still driving on. And the kid, he's keeping his eyes on the road like he should. Good driver there. All right, hope you enjoyed.